Today's topic, 2.3 real zeros of polynomial functions, the second day. We're going to be able to determine the possible rational zeros. If you're not given one, we can figure out what the possible ones could be. Again, they're just the possibles. If the polynomial of this form, f of x equal a of n, x to n, don't worry so much about that, has integer coefficients. Every rational zero of the function has the form p over q, where p and q have no common factors other than 1. P is a factor of the constant term a sub 0. Okay, so a sub 0, factors of the constant over factors of the leading coefficient. That determines the possible zeros that we can have. Let's show you an example. Okay, so listing all the possible rational zeros of the function. Let's look at problem A. What we want to do is look at the factors of p. Okay, the factors of p, factors of 9. 1 times 9, 3 times 3, and that would be it. Now we're going to look at the factors of q, which are the factors of 2. 1 times 2. So my list of possible factors then is I take my first number here and I write it as a fraction over my denominators. So it would be 1 over 1, so plus or minus 1. 1 over 2 would be plus or minus 1 half. Okay. Then I move on to the next number. So I move on to 9 now. Plus or minus 9, plus or minus 9 halves. Then move on to the next one. Plus minus 3, plus or minus 3 halves. This list is the list of all possible zeros. Now, they're all not going to be the zeros of the function, but they are the possible zeros. No, factors of p again. The factors of p. Doesn't matter about the negative sign because it's still going to be plus or minus 1 times plus or minus 2 over the factors of q. Factors of q, plus or minus 1, plus or minus 4, plus or minus 2. Now I'm going to simplify my fractions. Plus or minus 1, plus or minus 1/4, plus or minus 1 half. Now move on to 2, plus or minus 2. Now 2/4 is the same as 1 half, and I already have that in my list, so I don't write it down again. Plus or minus 2 over 2 is 1, it's already in my list, so I don't write it down again. So this is my list of possible zeros. Now moving on, it says to find all the real zeros of. All the real zeros of. Well, I'm not given any, so the first step I have to do is find the possibles. So my p, plus or minus 1, plus or minus 14, plus or minus 2, plus or minus 7. Now I could write that all over plus or minus 1, but that would still give me that exact same list. So I find the possibles, then I'm going to use synthetic to guess and check. So now I'm going to start with 1, my first obvious choice, and it's 1, negative 7, negative 11, positive 14. Okay, bring it down, multiply, bring it down, multiply. So this one does not work. Okay, so I go to another possible 0. Negative 1. 1. Negative 7. Negative 11. 14. Those are my coefficients again, so I test. And multiply, and add, and multiply, and negative 1 does not work. Sometimes it takes more than one guess to get where we're at. All right, so because I don't want to go to 14 next, because 14 seems like a rather large number, and so does 7, that I'm going to try 2. But I'm thinking that I'm going to try a negative 2, just from reasoning here, from these numbers with negative 1, it seems like it'd be more likely that negative 2 would be my 0. I don't know for sure, so I'm checking it. 1, negative 2, negative 9, 18, 7, negative 14. Okay, so my first 0 is negative 2. And what I have left is this quadratic here of x squared minus 9x plus 7 equals 0. Well, that's not factorable. I'm not going to complete the square because that's odd. So I'm going to use the quadratic formula. X equals opposite b plus or minus square root b squared minus 4ac all over 2a. X equals 9 plus or minus square root 81 minus 28 over 2. X equals 9 plus or minus square root 53 over 2. The square root of 53 cannot be simplified, so my other two zeros will be 9 plus or minus square root 53 over 2. And that's my answer. Those are my zeros. Look at another problem. All right. Now, looking at this, I'm thinking this list of possible numbers is huge. So I'm just going to start with just a few, and then I'll go on if I need to. Because I've got plus or minus 1 times 12, 2 times 6, 3 times 4, over plus or minus 1, 10, plus or minus 2, plus or minus 5. And if I start listing these out, I'm going to have a bunch of them. I'm going to have 1, 1/10, 1/2, 1/5, 12, 12/10, 6, 12/5, and so on. So where I like to start are my whole numbers. I'm going to start with 10. Well, not 10. I'm going to write down my coefficient 10, negative 15, negative 16, and 12. Start with 1. So that's 10. Bring it down, multiply, add, multiply, add, multiply. Okay, so that doesn't work. So I try to go again. All right, so it seems like 1 didn't work, but it seems like it was right on the right pattern here when I look at that negative. So I'm going to try a positive 2 next. Bring down the 10, multiply, add, multiply, add, and look, there's my 0. So my first 0 be 2. What I have left is this quadratic now of 10x squared plus 5x minus 6 equals 0. It's not factorable, And if I do try to complete the square and I take that 5 out, that's going to be odd, so I don't want to complete the square. So again, I'm going to do a quadratic formula. Equal opposite b plus or minus square root b squared minus 4ac all over 2a. Negative 5 plus or minus square root 25 plus 240 all over 20. Negative 5 plus or minus square root of 265 over 20. Now what I want to do is I want to check to see if the square root of 265 simplifies. So over here on my scratch paper, 5, and this would be 53, 250, yes, 53, and 53 doesn't simplify. So these are my other two zeros. Okay. Last one, find one more. Okay, in this case, we don't have a constant yet, but if I look, what does it all have in common? It all has a common x, so I'm going to factor that out first. So I know here, when x is outside here, x has to equal 0. So when I start my list of zeros, the first one I'm going to put down is 0. Now, what I'm going to do is I'm going to take that and find the possible zeros for that part of the function. Well, the possible zeros will be just plus or minus 1. So let's test 1. Oops, coefficients in here. 1, negative 5, 3, and 1. That's 1, negative 4. Okay, so 1 is also a 0. Now I have this left, which is x squared minus 4x minus 1 equals 0. Not factorable, but this is even, so I'm going to complete the square. So what am I adding to both sides? Negative 4 divided by 2, and then square it, would be a 4. So this is x minus 2 squared equals 5. Square root both sides. You get x minus 2 equal plus or minus the square root of 5. Now add 2. So the other two zeros in my list will be 2 plus or minus square root 5. And those are the zeros of my quadratic function.